Students, we are continuing with the interesting effects of very beautiful effects of refraction of light in its atmosphere, and all of us have known about that. I mean, in the maybe when we are in the kindergarten, there's a famous song about the twinkling of stars, twinkle twinkle little star. So now we are looking at what exactly is this twinkling effect of the stars. What is the physics behind it? So before going to that, we should understand a few things. The first point is that stars are very distant. Obviously, we know that stars are obvious. Of course, the nearest star is Sun, but we are speaking about other stars which are light years away, which means that stars should be considered as point sources of light. And second and more important thing is that now as we come towards the ground, I mean, as we come towards the sea level of the earth, the atmosphere becomes more and more dense. So here the height at which we see the star is quite high in the sky, which means that at that area the air is less dense. Then as we go down and reaches the ground level, that is the sea level, the earth, I mean the ground of the earth, the air becomes very dense. So you can see that there's a gradual increase in density of the air as we come down. I mean, as we come down from the position where we see the star. What this means is that as we come down, there's a difference in density of the air. That means the air density increases. Consequently, the refractive index of the air also increases. So if R1 is the refractive index of the air at a position where we see the star, R2 is something like below that, R3 again below that, and R4 is at the ground level. We can say that because the atmospheric density is greatest at R4, at R4, R is here referring to the refractive index, so at that position the refractive index is greater. So it will be something like R4 is greater than R3, which is greater than R2, which is greater than R, which means that as we go up, the air becomes lesser denser, which means that the refractive index decreases. Now this has a very important effect. In fact, it is a key cause of that twinkling effect. So here we explain the actual the key physics happening here. So as the point starlight comes down, we can see that as the light passes through the different dense layers of the atmosphere, that light is getting refracted, and the light, not the point, the light bends towards normal. So you can see that as the light is coming towards your eye, this is the eye, as the light is coming towards and as it passes through the more and more dense layers of the atmosphere, the refractive index changes, which means the refractive index is increasing, and the light is getting bent. So this is the normal, it's getting bent towards the normal. So that's a point. Now what is the total effect of this thing? The total effect of such a bending is that this is the actual position of the star, but this you'll be seeing the star a little upper than, which is so this is what is called the apparent position of the star. You'll be seeing the star a little upper than its actual position. So as I already mentioned, the star appears higher than its actual position when viewed near the horizon, and as we have already discussed, as the physical conditions of Earth's atmosphere is not stationary. I already told that there's a change in density as we go down, which means that the refractive index increases as we go. So that thing also means that this is the apparent position, but even the apparent position is actually not stationary. It will be something like there will be something like it changes a little distance up and down, something like that, which means that the apparent position of the star fluctuates. So the net effect is that you will feel like the starlight, that point starlight, it looks as if the thing is fluctuating, the thing is flickering, which means that sometimes the star may look a little more brighter, sometimes a little less bright. So the total effect, this effect is what is called twinkling of stars. So I hope this portion is very clear. Now a related question is that, okay, that's about stars. Then if why is it that the same thing is not happening with planets. Now, planets is entirely a different game. Why? Because on first point, planets are closer to it. Now, you know that solar system has something like around, I mean, if you include the Pluto, you have something like 9 planet bodies. So they are closer to Earth, which means that you should be considering them as extended sources. So this is a planet, and so on the understand that planet doesn't produce its own light; it's reflecting the sunlight. And if you consider it as point sources, there will be multiple point sources coming from the planet. And the interesting thing is that, so when there are multiple point sources of light, and when it is coming towards your eye, so suppose this eye, and so there are multiple point sources of light, which means that even though that I mean the points we discussed about the star, about the increasing density of there as we come down, the difference in refractive index, all those stuff is even though is applicable here also, because we are dealing with multiple point sources of light. I mean all of them, that refractive, the refractive path actually gets cancelled in the sense that when the light reaches the eye, there will be, I mean, all those point sources of light. If you take the net effect, that change in direction of the light, which is obviously meant by that refraction, that property of light, the net effect is that it's zero, which means that the total variation in the amount of light entering our eye from all the individual point size sources will average out to zero. So note this point. Even though the same conditions as stated with the stars is there, because of the fact that the planets are close to us, you have to consider it as multiple point source of light, and the net refraction from that multiple point source of light, when it reaches the eye, amounts to or sums up to zero, which means that there will be no twinkling effect as far as the planets are concerned. Thanks.